Hello everyone, I'm Sebastian Y and this is Principles of Microeconomics. In this video we're going to look at how to represent cost functions when we have continuous choices rather than discrete choices. Up to this point we've focused on firms that produce a discrete amount of output, meaning 0, 1, 2, 3, 4, and so on. That does not need to be the case, and we're now going to turn to a continuous choice world where we can choose any amount of output. So instead of 1, 2, 3, it could be 1, 1.5, 1 3/4, square root of 2, any of those numbers. You can think of the good that we're selling here as a liquid that you can pour out to any quantity. It does not have to be an integer. So for example, gasoline that you can have in third gallons, half gallons, and so on. When we shift our focus over to continuous choice, we can no longer use charts and schedules to represent cost functions, and so instead we're going to use equations. Let's go through an example. Suppose we have a firm that has a fixed cost of 300 and a variable cost that can be represented as 20Q plus 3Q squared. When we're going through this, Q will represent the quantity of output that our firm is producing. We can see that the fixed cost does not have a Q in it, it's just 300, and so when Q changes, the fixed cost doesn't change, and that's exactly the definition of fixed cost. On the other hand, our variable cost does have Q's in it, and when Q increases, variable cost is going to increase. If we want to know what our total cost is, we can simply add up our fixed cost and our variable cost. Now, if we know the quantity, we can just plug that into Q and figure out what the cost is going to be. So for example, let's suppose that quantity is 10, then our total cost is going to be 300 plus 20 times 10 plus 3 times 10 squared. That's going to come out to 300 plus 200 plus 10 squared is 100 times 3 is 300, and so that's going to be a total cost of 800. Next, we're going to figure out what our average fixed cost will be. Remember that average fixed cost is fixed cost divided by quantity. It tells us how our fixed cost is spread out over all of our output. In our example, it's going to be 300 divided by Q. What do we notice about this? As quantity gets bigger, average fixed cost is going to get smaller. Because fixed cost doesn't change, we're dividing that same number by a bigger and bigger number, so AFC decreases. Average variable cost is defined much the same way. Variable cost divided by quantity is going to be 20Q divided by Q plus 3Q squared divided by Q. In that first part, the Q's cancel, and in the second part, we've got Q squared on the top, Q on the bottom, so one of those Q's is going to cancel. We're left with 3Q. Next, let's figure out the average total cost. There are two ways to do this. We can either take total cost divided by quantity, or we can add up the AFC and the AVC. We'll get the same answer either way. And it's going to be 300 over Q plus 20 plus 3Q. The final cost curve that we need is the marginal cost. Now that we're in a continuous choice world, the marginal cost is a little bit more difficult to figure out because we need calculus. The definition of the marginal cost is the derivative of the total cost function. But since we're going to avoid calculus in this course, I'm just going to give you the marginal cost. In this example, it is 20 plus 6Q. What I do want you to focus on is think about the shape of this marginal cost curve. It has an intercept of 20, so when Q is 0, marginal cost is 20. But as Q gets bigger, we can see that marginal cost is going up because of the 6 sitting there. Therefore, this aligns with our general idea that marginal cost rises as quantity goes up. Now we're going to graph. I'm going to put quantity on our horizontal axis, and I'm going to put all our cost concepts on our vertical axis. First, let's graph the MC. I'm going to mark out 20 here because we know that is our intercept, and it's going to be an upward sloping line. Now I want to graph our ATC. I'm going to rewrite that just so we have it. It's 300 over Q plus 20 plus 3Q. Before we draw this, let's think about the shape that this has. When Q is really small, the 3Q part here is also really small, but the 300 divided by Q is going to be big. 300 divided by a small number is going to be a big number. But when quantity gets really big, when we divide that 300 by a really big number, that part doesn't mean as much, but this 3Q will start to mean more and more as Q gets bigger. And so in general, when Q is small, ATC is going to look more like 300 over Q, and when it's big, it's going to look more like 3Q. The result of this is that it's going to have kind of a U shape, where it starts really high, comes down, crosses over the MC, and then starts to come back up. I don't expect you to be able to draw this perfectly. I certainly don't expect to do that myself, but we can get the right idea and get some of the basic facts right. The main thing is that we get our efficient scale right. That is the point at which ATC is at its lowest. That's also the point where the marginal cost crosses over the average total cost, meaning that MC and ATC are going to be the same. So we're going to write out an equation, 20 plus 6Q equals 300 over Q plus 20 plus 3Q, and then we're going to solve for Q. First of all, the 20s cancel. Then I'm going to subtract 3Q from both sides. So we're going to get 3Q on the left, and we still have 300 over Q on the right. We're solving for Q, so I'm going to multiply both sides by Q, and I get 3Q squared equals 300. Then divide both sides by 3 to get Q squared equals 100. Square root both sides to get Q equals 10. Now we need to know what our average total cost and marginal cost are at that point. We can plug it into either one and we'll get the same answer because we know they have to be equal. So if we plug it into our MC, we get 20 plus 6 times 10, which is 80. And just to check our work, our ATC, 300 over 10 plus 20 plus 3 times 10. 300 divided by 10 is 30, and 3 times 10 is also 30. That looks like also 80, and so that all checks out. That means we need to find 80 on our graph, which will be about here. And that is going to be our crossing point of our ATC and our MC. We know that that happens at Q equals 10 because we solved for that earlier. Now we can go ahead and sketch our average total cost. As I said before, it doesn't have to be perfect, but we need to make sure that its lowest point happens at that point we just found. It's going to start out big, it's going to come down, and then cross over MC at its lowest point, and then it's going to start coming back up. So when you're drawing these, make sure this all looks right. Things to watch out for as well are the intercepts for the MC. Make sure that's not coming out of the origin unless it's supposed to. So think about that intercept, think about that efficient scale, and you'll be all right. And that is it for our material on production and cost. If you have any questions, please let me know. Thanks for watching.